1, and you just keep multiplying in descending integers until you get to down to 1. I should note that, and I didn't write this, but n should be an integer. Okay? Although I remember when I was, there is something called a half of a factorial. I remember when I was in integral transforms, we actually proved like what a half of a factorial is. It's completely useless, but I mean that's the only thing I really remember.
Another thing, zero's factorial is 1.
What's that?
Zero's factorial is 1.
Right, 0 factorial is 1. Okay, so if you ever ran into that,
You didn't write that, yeah.
yeah, 0 factorial is 1, if you ever run into that. If you ever have to suffer through a statistics class or a probability class, that'd probably be a place where it's useful. For our class, it's not really useful.
The birthday thing, right?
What's that?
How many people share the same birthday?
Oh yeah, like the birthday problem. Like the probability is like if you're in a room, the probability that you probably share a birthday is pretty high, believe it or not. All right. So let's just go ahead and evaluate or simplify some of these, and then we can be done with this stuff. Okay, and let's try not to use a calculator. So I have 5 factorial. Okay, so 5 factorial is just going to be expanded. That's 5 times 4 times 3 times 2 times 1, right guys? Okay, that's all a factorial means. Just multiply in descending integers until you get down to 1. You don't want to go to 0 because, well, then it just multiplies to 0. Okay. If we do this by hand, 5 times 4, that's going to be 20. 20 times 3 is 60. 60 times 2, 120. Although, I don't know if you want to believe me, since apparently I can't add. Oh, but this is multiplication, so I guess it's okay. All right, thank you, sir. I appreciate it. All right. Guys, does that make sense as to what a factorial is? It's not difficult. Okay, you just multiply in descending integers. Now, for item B, now this one's a little bit more difficult. 18 fact over 16 fact. Now, if I asked anybody in class what 18 factorial is off the top of their head, they'd look at me like I had 19 heads, because 18 factorial is just a ridiculously huge number. In fact, your calculator might just spit back the scientific notation of this, right? So if anybody tried to figure it out, it's just ridiculously huge. But I asked you guys to compute it by hand, which makes things even worse. Go ahead, Don. No, tell me something.
Since the numerator will cancel up to 16, all you gotta do is do 18 times 17.
Yeah.
Very good.
Yeah, because isn't it true, guys, that the definition of 18 factorial would be 18 times 17 times 16 times 15, all the way down to 1, right, guys? The definition of 16 factorial would be 16 times 15, all the way down to 1. And Don, you suggested that everything from 16 down to 1 are just going to cancel out, right? Because we're dividing them, okay? So it's not a collapsing series necessarily, because it's not a series or a sequence, but it's a collapsing form of something. So really, guys, aren't we just left with 18 times 17? If we really had to do it by hand, we could, okay? But of course, we're lazy, so we're just going to stick it into our calculators. Although 18 squared is going to be 324, so 324 minus 17, that's going to give us what, I guess 307? What's that? Oh yeah, minus 18, so that might be difficult. So that would be 306? No?
Yeah.
Okay, there we go. Thank you. Oh, you cheated. That's okay.
I had no idea what 18 squared was.
Oh, that's okay. Neither did I. I was just making up shit. I have no idea. Although you are right. I probably should subtract the right number.
Yes, that would help.
Yeah.
It was multiplication. That's what was the
Yeah, I did okay with the multiplication, but then when I had to do addition and subtraction, I screwed that up. So once again. Okay. Does that make sense, guys? If I give you guys bigger numbers, easy to manipulate. Okay. What if I just had variable stuff? So let's say, for instance, I had n plus 4 fact, and I divided that by n plus 2 fact. Okay. Now, regardless of what the value of n is, we can still simplify this. In fact, we kind of already know what's going to happen with this, because isn't this the exact same sort of thing, where we have 2 more terms or 2 more factors in the numerator than the denominator? But we want to simplify this. So if I was to ask you guys to expand n plus 4 fact, okay? The first factor is n plus 4. What's the next factor?
N plus 3.
Right, because we just go down one integer. So it would be n plus 3. Next integer down would be n plus 2. Next integer down would be n plus 1. And that would keep going on until we got to 1, right guys?
Now, wouldn't it be okay to just put n plus 2 with the factorial
Absolutely.
next to it? And
Correct.
right over it?
Because this animal right here is really just n plus 2 fact. Right, James?
Mhm.
Okay. So if you can see that, that's fine. Okay. And some of us are really good at seeing factorials, but some of us have never worked with factorials before. So I just want to make sure that if you've never worked with a factorial, that's how you work with it. The denominator, n plus 2 times n plus 1, 3, 2, okay? And clearly, all this stuff is going to cancel out, right guys? So we're just left with n plus 4 times n plus 3. And if we really wanted to, we could FOIL that out, right guys? So if we FOIL it out, we would get n squared, 4n, 3n is 7n, and then 12. So n squared plus 7n plus 12. And the good news is none of those are like terms, so I don't have to add them together, which means I can't make a mistake on.
But Chris, you have to remember, multiplication is just addition, repeated.
Don't make me feel any worse than I already do. All right. Does that make sense, guys? When you guys are in your Calc 2 class, you guys might remember seeing like your ratio test, and you probably did this a lot on the ratio test. Okay. Let's just do our last one here, and then we can be done with this stuff. So we have n fact over n minus 2. So we have n fact over n minus 2. Oh, by the way, if you've never taken Calculus 2, I know I keep referencing Calc 2 because this is the place where you might most likely see this. I'm not trying to exclude people that haven't taken Calc 2. I just want to let you know that it is used for something, and for those of you guys that have taken it, I'm just trying to make as many connections as I can. Okay? So, let's expand the numerator and expand the denominator. Okay? If I was to ask you guys the definition of n factorial, well, we know that. That's n minus 1, n minus 2, all the way down to 3, 2, 1, right guys? Because we just continuously subtract 1 each time we go down to the next integer. Okay. What about the definition of n minus 2 factorial? That's n minus 2 times what, guys?
N minus 1.
N minus,
1.
nope,
Minus 3.
3.
right. Because remember, you're going down. You're going away from it.
Okay, okay, okay.
Okay, does that make sense, Art?
Yeah.
Okay, so don't ever do that again, please. Okay. Times n minus 4, all the way down to 3, 2, 1. So, is that okay with everybody, guys? Any questions about how to simplify that animal? Okay. Obviously, everything from n minus 2 all the way down to 1 is going to cancel out. So we're left with n times n minus 1, otherwise known as n squared minus n. And again, no like terms, so I don't have to make any errors. But I either try to multiply or repeatedly add or whatever. Okay. Guys, this makes sense about factorials. Not meant to be difficult. Okay. These are like the types of questions I like to ask for, like those 2-point questions that'll be on the next exam, like the quickly stuff. Okay. All right. So you guys can work through everything that's on assignment number 6 right now, but it's not going to be due until next Monday. So my suggestion would be go ahead and get a head start on that, especially the proof problems at the beginning. Try to knock those out, and then if you guys want on Wednesday, I can certainly answer some questions. Okay? All right. So if you guys have questions, stick around. If you don't have any questions for me, then I would be happy to leave a little bit early, as I'm sure you guys are. All right. And then next time we're going to go